For over 40 years, science has warned the world's population of the potential climate change connected to overconsumption and mainly of fossil fuels. Emissions continue to rise, carbon dioxide levels are still increasing, and up until today, we have failed to complete any of the commitments in the Paris Agreement. I am Tommy Vince, and I'm going to talk about how architecture can save the world. Sorry, it's not moving. How architecture can save the world against global climate change. Because, quote, nature doesn't have a design issue, humans do, end quote. Society has been inducing carbon to the terrestrial layer by burning fossil fuels since the Industrial Revolution. The result is rising global temperatures far beyond normal climate variations. The United Nations Climate Panel, IPCC, has together with the world's leading scientists summarized the reality of the situation. Quote, limiting warming to 1.5 degrees Celsius implies reaching net zero CO2 emissions globally around 2050, and some form of carbon dioxide removal with carbon storage on land or sequestration in geological reservoirs, end quote. The IPCC follows up with the projections of global temperature levels with this statement in mind. The best projections indicate a fossil-free society, together with solutions which absorb and capture terrestrial carbon by restoring it to subterrestrial layers. Yet, the IPCC doesn't offer any suggestions on which strategies should be applied, though it's pretty obvious which strategies shouldn't. Throughout the rest of this presentation, the term sequestration will be used to refer to actions and processes with a positive net emission exchange, or NEE, meaning that more carbon is retained in the material than what is produced or released, producing it. In regards of sequestrating methods, there are two main paths to go down, artificial and natural. Natural sequestration appears in vegetation through the known process of photosynthesis. Carbon dioxide becomes, with much help from the sun and some water, oxygen and sugar. What we're really interested in here is the sugar, which is a chemical chain including carbon. Vegetation uses the sugar to build its growth, just like any living being on the planet. Thus, vegetational sequestration appears through the accumulation of mass. The other way to go down is the road of tech optimism. The number of options grow by the day as the increasing market interest arises due to the contemporary climate debate and subsequently rising prices on carbon emission rights. Similarly, a potential economic opportunity for this project. Though to be able to manage the equation of retaining carbon, then you must be able to solve the equation of retaining more energy than what is used to retain it. In other words, you either find an external sustainable power source, or you're talking about the perpetual machine, or even better. The last of which doesn't exist in the laws of physics. While on the other hand, the first can be offered, for example, on Iceland. Yet some skepticism ought to be raised in regard to the analyzed result of a total life cycle analysis. Which is why it seems sensible to go for option of natural sequestration. With the ambition of architecture contributing to the carbon sequestration, then choosing sequestrating materials to build with is step one. And I will gladly discuss the choice of wood over other vegetational materials for this project later, but for now, let it be said that the choice of sequestrating vegetation is Taigan forest timber, meaning primarily pine, spruce, and birch. The taiga forest is the largest land biome in the area of Umeå and Västerbotten, which coincidentally also is the world's largest land biome. And in the aspiration of reducing the global carbon dioxide level, volume, of course, does become a factor. On the topic of vegetational sequestration, it must be clarified, and this is immensely important and frequently misunderstood in our profession, that wood and all vegetation are only carriers of carbon as long as it remains solid. Demolishing wooden structures and not successfully securing the mass to a sequestrating state only returns the carbon back to the atmosphere. The result seen to the furthest right here in the diagram. So the reasonable question is, how does architectural mass remain solid for an extensive period of time to achieve a true carbon sequestration? An architecture that doesn't get demolished or renovated. An architecture that was never recycled, consumed, burnt, or in other ways exploited. The strategy applied to the proposal derives from the theory of buildings' material life cycles, which I have divided into sequestrating or optionally non-sequestrating layers. For the sequestrating mass, this means that we can reconnect with nature and its natural decomposition, a non-conservative relationship to architecture, expressing itself as the following, thus ultimately becoming key attributes and characteristics in the project. Yeah, and sorry, I'm deviating a little bit here, but I just quickly want to include a quote of something that I found quite beautiful for the mind. And it's something that an artist here in Sweden said on the topic of forests. The forest belongs to everyone except the trees. So to the proposal. Swedish citizens will offer global industries carbon emission rights through the exchange of harvested building materials. The building is assembled by electrical wind-powered machines and vegetarian-fueled manpower. Later, the protagonists can move in. Mass is accumulated through the vegetational growth and mass additives connected to consumption, seen also here. The construction sinks under compression and aging. Stage 1, sealing the architecture and boosting its decomposure. Towards the end of its use, non-sequestrating materials are disassembled and removed for reuse. The owner's burial ceremony is carried out, where the building will perform as a tomb, just like in the pyramids. The building and its former user is left in resting state. The building begins to implode upon the voids. And the sequence of this decomposition is well documented within the topic of Nordic timber log in buildings. First, of course, the failure of the roof. Water entering the interior, decomposing primary beams, the floor, destabilizing the wall structure and allowing them to cave, giving a poetic expression to the building as relational key elements begin to fall off, inevitably leading to a total collapse. Please notice the resilience in the wall knots. I'll get back to this later in my proposal. Architecture to soil, to memory, to successful carbon sequestration, towards a new plot for following generations, reforested. The proposal is, of course, an all too well-known architectural topography to a Swede, yet a revitalized function for the society's contemporary issues. The timber log construction is quite genius in the sense that it performs precisely the desired result in regard to this project. The detailed section of the wall seen here shrinks and sinks under the force of compression and time. The proposal actually consists of a 600-year-old Swedish timber log construction based on the knot joint called Dala Knut, with light moderations, which in a section here concludes the accumulated knowledge up until today, ultimately resulting in a proposal which speaks about the understanding of where not to innovate, seen from all sides. Further accessing the knowledge of Swedish culture and contemporary forestry to inform dimensions. Variations of ratios and dimensions, diagrammatically illustrated here, from 3x3 to 10x10 meters. Applying the comfort and standards of today's insulating requirements and reducing the knot extensions to speed up the buckling of the wall. In doing so, counteracting the resilience seen before in the photo of the collapsed building. The desired knot results seen here, and the aging aesthetics with the exposed insulation. The unit along the long section cut, thick cedar roof inspired by the traditional context, and a large insulating volume that will help cover and fill the building once it becomes a mount, securing the carbon binding mass in sequestrating state. The window detail in section, allowing a full facade glazing and the sinking of the roof trusses, seen over time. The unit's short section, embodying an empirical reading of the Swedish timber log heritage into a contemporary expressive unit, true to the fundamental element of horizontality and compression. The roof in detail, cedar roof with a thickness of 1 meter with a traditional sequestrating weather layer of birch bark, seen here as it decomposes, and also here. Non-sequestrating materials such as glass is designed to allow a successful reassembly on other unit generations by simple means of attachment with silicone glue. The attention to designing for reassembly is equally noticed on the service elements, which most likely are non-sequestrating materials, seen here in the floor section detail. Adaptable, accessible, and readable. Pay attention to the foundation element, which is designed to rot away within 50 years and grant the unit an additional 600 millimeter of sinkage. Its aesthetic in decomposing state, unveiling the joining dowels to the left. The elevation of the unit seen over a 50-year-long time period. The unit in perspective and in a decomposing context. Combined units in a plan forming a collective residence. Not going into all the details of the program, but it kind of configures itself into contrasting sheltered with the climate exposure, a sensory and climate present experience that reminds the protagonist of what it is, an element of climate. The proposal also includes notions of transformability by additive units if one needs some extra space, seen here in low opacity to the left and down at the bottom. Section of the same residence with the inner garden courtyard and retaining walls. Elevation from the north facade, passing through the mound. These are, of course, subjective proposals to the unit with plenty of combinations and variations. From the knowledge and reading I have achieved during this project, which gives me the arguments to propose something that relates back to its historical context while retaining its architectural performability. Yet it's totally up to the user to propose their own. The project multiplied over time will accumulate and form a new topography of mounts, talking about a metabolic rate of architecture in our society. And finally, the rendered timeline of the proposal. Built on peripheral areas of the city on cheap, unstable green land. Compressing the urban space just like any ring wall has done in medieval cities, resulting in a densified, highly temporary, ever-changing cosmopolitan urban fabric. Creating a question of dynamics over what is really intruding over what. And finally, forming mounds of sunken architecture, subterrestrial textures, a memorial site of unstable, constantly shifting ground, a topography that speaks of a history, just like peripheral burial sites in Nordic Viking cities did. Renzo Piano is known to have said that, quote, architects spend their entire life with this unreasonable idea that you can fight against gravity. I can see how that is true for the architects born through Renaissance ideologies, stuck in the preconception of man over nature. Though for me and my generation, the reality is real. To this generation, gravity belongs. And if one chooses to embrace it, it has the power to perform something quite beautiful. This might just be how architecture can rise to the United Nations global call against climate change. This might be a way to re-embrace a non-conservative relationship to nature. Maybe it is a proposition for Swedish cultural and architectural heritage as a media to regain footing in contemporary Sweden. But more importantly, my project is about this, for what it really does today is propose a new benchmark for sustainable architecture to the field of green certifications. With this project as a new reference point, yesterday's sustainable architecture will not perform even close to the net result. And that is worth debating here. For the future where the architectural industry needs to relate to an actual and truthful sustainable architecture is one that has the chance to answer to the demands of today. Thank you very much.